Hey everyone, today I'll be going over Leetcode 1347, minimum number of steps to make two strings anagram. So we're given two strings basically, and in one step you can choose any character of one string and replace it with another character. So basically you have to count the minimum steps to make them equal by doing these replacements. So just very simply, let's take a test case as I always do and put it there. So we have these two strings, they're not anagrams yet. So to be an anagram, two words basically need to be structured in a way that you could shuffle them around to make them equal. So what it means is, do they have the same occurrent counts of each character? So S here has two B's and one A, and T here has two A's and one B. So basically, to make these equal, we have to do this steps logic. So we're trying to find the minimum number of steps. So really all that we need to do here is just turn one of these A's into a B and T, or one of these B's into an A and S. Either one works. So basically you could just replace that A with a B here, and these are anagrams, because see how now there is two B's, one A here. So these are now anagrams. So it's one step, and if we look over here in the example, the output is 1. So it matches what we're expecting just by doing that on paper. So basically now, what we want to think about is how we're going to approach this. So really all we need to do is count the occurrences in each anagram. And the proof is if these are completely equal, if the strings are completely equal or they already are anagrams, the occurrences should be completely balanced. So really we're just counting the characters that are unbalanced. So to track this balance, we're going to have a counts array. So as normal, we'll do a counts array of 26. Now the reason why we do 26 here is because if we look down in the constraints, these can only contain lowercase English letters. So this 26 will just be the 26 lowercase English letters. So next what we want to do is go through both strings simultaneously. If we also look at the constraints, these lengths will always be equal, so we can make that assumption. So let's go through them at the same time, and we'll just do a simple for loop. And basically we want to, as I said, we want to make sure that both of these strings are balanced. And if they're completely balanced, that means they already are anagrams. So basically, to track this balance, we need to increment one of the strings counts and decrement the other string count. So we'll use S as the increment. So let's go counts s.char at I minus A plus plus. Now we do this because, as I've said in another video, maybe you haven't seen it, basically if the character is A, minus A will be 0, so that'll be like mapping to 0 in this counts array. So as I said, we want to make sure the balance, so we also want to do the same thing but decremented to T. So see increment S, decrement T, so this will like track that balance. So right here intuitively you can tell, if these are anagrams, this counts, every single character should be 0, because there will be an equilibrium, like we'll plus and minus an equal number of times, every single one should be 0. So what does that tell you? If they're not anagrams, the ones that are non-zero means they're not balanced, and we have to make some character swaps. So let's have a result, and let's return that result at the end, and let's actually just do exactly what I said. Let's just count the character occurrences, or the unbalanced characters, and sum them up, because those are the amount of steps that we'll have to make for those replacements. So let's just go through each count, and I'll make it count to be more clear, and let's just sum them up. So we'll go res plus equal count. So the thing is that's tricky is that you want to do this, but you can't really do it this way, because some of these are going to be negative counts at the if it's not balanced, because some will be negative. We really just want the positive ones. So what we're really actually going to do is if count is greater than 0, we'll go res plus equal count. Because really, if we replace one of the characters, we don't need to replace the other one, because we could just make those characters equal. So we don't actually need to account for every non-zero count, just the positive ones. And let's run this. And it looks like that's good. Let's submit this. And yeah, it looks like this is a pretty good interview solution. Now let's talk about time and space. Space is easy, it's constant. The reason being is the only space we use is this counts array, and it's bound to a fixed constant value of 26. Time is on. The reason being is we just have this loop here, which is on. And then we have this loop here, which is O26 or O of 1 or whatever, simply because this is bound to that 26 value up here. So really it's O of 1 space O of n time, where n is the length of S and T. So yeah, I hope this helped. As I said, this is a medium, but it's really an easy problem. So thank you for watching.